Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. We are on chapter 11, that is the organic chemistry, and the topic that we will discuss today is the functional groups containing carbon, hydrogen and oxygen. We will discuss about the classes of compounds containing these three elements. The first category of the classes of compounds containing these three elements is those of alcohols. In alcohols, the functional group is OH. Now, if you look at the structure for this compound, this is an ethanol, and this compound contains three elements: carbon, hydrogen, and oxygen. Second category is those of ethers. In ethers, oxygen atom is present at the center of two alkyl groups. Third category is that of carboxylic acids. In carboxylic acids, we have the functional group that is C double bond O attached with OH. Now, any class of organic compound, any organic compound containing this C double bond OH group will be considered as carboxylic acid. If you look at the structure of this compound, that is ethanoic acid, you will see that this compound is made of only three elements: carbon, hydrogen and oxygen. Fourth category belonging to the classes of compounds containing carbon, hydrogen and oxygen is that of aldehydes. In aldehydes, the functional group is C double bond O attached with a hydrogen atom on one side and the alkyl group on the other side. Fifth category is those of ketones. In ketones, the carbonyl group is present between two alkyl groups. And the last category is those of esters. In esters, we have the functional group C double bond O. This carbonyl carbon is attached with the oxygen atom on one side and may be attached to the alkyl group on the other side. Now, in esters, this single bonded oxygen atom is attached with the carbonyl carbon on one side and with the alkyl group on the other side. So these were the classes of organic compounds containing three elements: carbon, hydrogen and oxygen. In our today's lecture, we will study about the alcohols and ethers in detail. The word alcohol is derived from an Arabic word meaning alcohol. This word means fine powder or an essence. However, in chemistry, this term was used for any substance which is obtained through the process of distillation. For example, the rectified spirit was considered an alcohol because it was obtained through the process of distillation. What is distillation? Distillation is the process of purifying liquid through heating and cooling. Now, this rectified spirit is generally the pure ethanol, and it was called alcohol because it was obtained through the process of distillation. In organic chemistry, these alcohols are characterized by the presence of OH group. So all the organic compounds having OH group will be called as alcohols. The general formula for alcohol is ROH. Here R is representing an alkyl group. Here are the examples of some compounds belonging to this class. First one is that of methanol, second ethanol, and third propanol. Now you may see here that each compound contains this OH group attached with an alkyl group. Now in propanol, this OH group is attached with propyl group. In ethanol, OH is attached with an ethyl group. In methanol, OH group is attached with a methyl group. If you look at the names of all these substances, then you will see that each substance name is ending with the word ol. So for all the alcohols, the suffix ol is used. We have read before that in the organic compounds, the suffix basically represents the class of that organic compound. So this ol is used as a suffix here, and it is representing which class of organic compound? Alcohol. So for naming all these substances having OH group, the suffix ol will be used. For alcohols having 3 or more carbon atoms, location of OH group is also mentioned in their names. For example, we have a substance that is the propanol. Now, this OH is a substituent here, and in order to number or in order to locate the position of OH group in this chain, we will number the carbon atom like this. Now, since OH group is attached to the first carbon atom, so therefore it will be called as 1-propanol or N-propanol. However, if this OH group is present on the second carbon atom, then it would be called as the 2-propanol or isopropanol. So for alcohols, the organic compound having 3 carbon atoms or more than 3 carbon atoms, the position of OH group will also be mentioned. When OH group is attached to a benzene ring, then it is called as phenol. The structure for phenol is like this. Now you may see here that this is a benzene ring, and this ring contains carbon atom. Each carbon is attached to a hydrogen atom. Now, when one of the hydrogen atom gets substituted by OH group in a benzene ring, then that compound will be called as the phenol. This phenol was used as an antiseptic in Operation Theater. This antiseptic means that it is used as a germicide. Now moving towards another class of compound belonging to this category, that is ethers. What are ethers? Ethers are the pleasant smelling colorless liquids, and these are the organic compounds in which oxygen atom is attached to 2 alkyl groups. General formula for ether is represented like this. Here you may see that the oxygen atom is attached with 2 alkyl group and is present at the center. Now these alkyl groups may be same or may be different. Examples for ether includes diethyl ether. Now in diethyl ether, this one is an alkyl group and it is also an alkyl group. These 2 alkyl groups are attached to each other with the help of an oxygen atom. Now if you look at these 2 alkyl groups, these 2 alkyl groups are same. Now this compound is called as ethyl methyl ether. In ethyl methyl ether, at one side of the oxygen atom, the alkyl group is ethyl, and on the other side the alkyl group is methyl. So this is an example of ethers in which the two alkyl groups attached to the oxygen atom are different. So all the ethers will be recognized by the presence of the oxygen atom attached to the two alkyl group on both sides through a single bond. Now let's do a self-assessment exercise. We have to differentiate different organic compounds on the basis of their functional groups. So first one, in this case, a condensed structural formula for a compound is given, and it is said that it is used as an anesthetic, but its use as anesthetic is now limited. This is because it is inflammable and causes nausea. Now we have to classify it as an alcohol, phenol, or ether. If we look at the structure of this compound, condensed structure formula for this compound, you will see that there is the presence of oxygen atom between two alkyl groups. Now we know that all classes of organic compounds having this general formula will be classified as ethers. In this case, the alkyl group is CH3CH2, that is ethyl. Now moving towards the option B, we are given a compound. This is the condensed structural formula for a compound. It is used as a strong germicide, and it is commonly used as disinfectants for floor, furniture, and the washroom. So what is it? If you closely look at the structural formula for a condensed structural formula for this compound, you will see that this C6H5 is derived from C6H6. C6H6 is the formula for benzene. Now if we remove one of the hydrogen atom from benzene ring and substitute it OH group, then we will get a class of organic compound name as phenol. We just read about the phenol. We just knew the structure of phenol. So this C6H5OH is a phenol. For the third one, CH3OH is poisonous and can cause blindness or death if taken internally. What is it? Now here, this OH group is attached to an alkyl group. The alkyl group here is CH3. So the general formula for this compound may be written as ROH, and we know that all compounds having this OH group will be classified as alcohols. So CH3OH is an alcohol. Now here is a self-assessment exercise 11.7. Classify the following compounds as alcohol, ether, or phenol. So for A compound, first we would distinguish the alkyl group. Now this CH3CH2 and the CH2CH3, these two are the alkyl groups. Let me write this condensed structural formula for this compound. Now this is an alkyl group, this is also an alkyl group, and between two alkyl group oxygen atom is attached. So therefore this compound is an ether. Now for the structure present in the option B, first we will distinguish the alkyl group in this compound, and then we will look for the functional group. Here This is an alkyl group and the functional group attached with this alkyl group is OH. So therefore this compound will be an alcohol. Now for this compound, the C6H5OH. C6H6 is a molecular formula for benzene. We removed a hydrogen atom and substitute it with OH. Now since this OH is attached with a benzene ring, therefore it would be a phenol. For this compound, we have C2H5OH. Now this C2H5 is an alkyl group and this OH is a functional group. Since OH is attached with an alkyl group, therefore it would be an alcohol. The name for this compound is ethanol. So this was all for today. We will discuss about the next classes of compounds belonging to this category in our upcoming lecture. Thank you for being with me.